Picture this. You're lying in bed. The world outside has gone quiet, and your mind is ready to drift into the realm of sleep. But tonight, instead of counting sheep, we're going to journey back through millions of years to meet some of the most extraordinary creatures that ever walked, swam, or soared across our planet. These are the stories of animals that once ruled the earth. Creatures so magnificent and bizarre that they seem almost mythical. Yet they were real, breathing, living beings that shaped the very world we inhabit today. Welcome to 3 hours of extinct animal facts designed to gently carry you into peaceful slumber. Tonight, we'll explore the fascinating lives of creatures that vanished long before humans ever set foot on Earth, and some that disappeared much more recently, leaving behind only fossils, bones, and the echoes of their existence in our collective memory. Our first stop takes us to the frigid landscapes of the Ice Age, where massive creatures roamed across vast tundras and grasslands that stretched from one horizon to the next. These were lands of extremes, where survival meant adapting to some of the harshest conditions our planet has ever known. The woolly mammoth stands as perhaps the most iconic of all Ice Age giants. These magnificent elephants were perfectly engineered for life in a frozen world. Standing up to 11 feet tall at the shoulder and weighing as much as 6 tons, they were living fortresses against the bitter cold. Their most remarkable feature wasn't just their size, but their incredible coat of fur. Beneath their coarse outer hair lay an undercoat so dense and insulating that it could keep them warm in temperatures that would kill most modern animals within hours. These gentle giants possess curved tusks that could grow up to 13 feet in length, tools they used not for warfare but for survival. They would scrape away snow to reach the grasses beneath, strip bark from trees, and even dig into frozen ground to find roots and other vegetation. Their trunks, like those of modern elephants, were incredibly versatile instruments capable of delicate manipulation and powerful lifting. What makes the woolly mammoth particularly fascinating is how recently they vanished from our world. While most disappeared around 10,000 years ago as the Ice Age came to an end, small populations survived on remote islands until just 4,000 years ago. These island mammoths, isolated and gradually shrinking in size due to limited resources, represent some of the last chapters in an evolutionary story that spanned millions of years. The mammoth's social structure mirrored that of modern elephants. They lived in matriarchal herds, led by the oldest and most experienced female. These family groups would migrate vast distances following the seasons, their massive feet creating paths that other animals would use for generations. Baby mammoths, covered in dark brown fur, would stay close to their mothers for years, learning the complex knowledge needed to survive in their harsh world. But the woolly mammoth wasn't alone in its frozen domain. Sharing these ancient landscapes was another remarkable creature, one that proved to be far more resilient to the changing world. The musk ox, a living relic from the Pleistocene era, somehow managed to survive when so many of its contemporaries perished. These stocky, powerful animals developed one of nature's most effective defense systems. When threatened, musk oxen would form an impenetrable circle, adults facing outward with their formidable horns while the young sheltered safely in the center. This strategy proved remarkably effective against the predators of their time, including massive cave bears and dire wolves. The muskox's secret to survival lay in their incredible efficiency. Unlike other large mammals that needed to migrate vast distances to find food, muskoxen could remain in one area for extended periods, conserving energy during the long, brutal winters. Their thick coat, particularly the soft undercoat called kiviot, provided insulation 8 times warmer than sheep's wool. This remarkable adaptation allowed them to stand motionless in howling blizzards, barely burning any calories while waiting for better conditions. What's truly remarkable about muskoxen is their ability to thrive on vegetation that would barely sustain other animals. They could digest tough Arctic grasses, sedges, and willows that most creatures would find inedible. This dietary flexibility, combined with their energy-efficient lifestyle, helped them survive the great extinction that claimed so many of their Ice Age companions. Interestingly, muskoxen disappeared from certain regions only to return thousands of years later through human intervention. In some areas of Siberia, these ancient creatures had vanished 3,000 years ago. Yet when reintroduced in modern times, they adapted as if they had never left. It was as though the landscape itself remembered them, welcoming back these living links to a bygone era. The relationship between these Ice Age survivors and their environment tells us something profound about adaptation and resilience. While the massive woolly mammoth, despite all its impressive adaptations, couldn't survive the warming world and changing landscapes, the humble muskox found a way to persist. Sometimes in nature, it's not the largest or most impressive creature that survives, but the one most perfectly suited to endure whatever changes the world might bring. As we journey deeper into the world of extinct animals, we encounter creatures that challenge our understanding of what life on Earth once looked like. The saber-toothed tiger, or more accurately, the saber-toothed cat, represents one of evolution's most dramatic experiments in predatory design. These weren't actually tigers at all, but belonged to an entirely different family of cats that developed their distinctive fangs independently. The most famous of these prehistoric predators was Smilodon, a powerfully built cat that stalked the Americas until about 10,000 years ago. Unlike modern big cats, which are built for speed and agility, Smilodon was constructed like a living battering ram. Its front legs were incredibly muscular, designed to wrestle down prey much larger than itself. Its shoulders were massive, providing anchor points for muscles that could deliver devastating power. Those iconic fangs, which could grow up to 7 inches long, weren't used the way you might expect. Rather than slashing and tearing like a modern lion or tiger, Smilodon would use its incredible strength to pin down its prey, then deliver a precise bite to the throat or belly. The long canine teeth were actually quite fragile and could break if used incorrectly. So these cats had to be surgical in their approach to killing. What's fascinating about saber-toothed cats that they evolved this specialized hunting technique multiple times in different lineages. It was such an effective strategy for dealing with large, thick-skinned prey that nature kept returning to this design. During the Ice Age, when massive ground sloths, ancient bison, and young mammoths roamed the landscape, having the tools to bring down such formidable prey was a significant advantage. The extinction of saber-toothed cats coincides closely with the disappearance of many large Ice Age mammals. As their preferred prey vanished, these specialized hunters found themselves unable to adapt to a world of smaller, more agile animals. Modern cats succeeded where saber-tooths failed because they maintained the flexibility to hunt a wide variety of prey. It's a reminder that sometimes being too specialized can be a disadvantage when the world changes rapidly. Moving from land to sea, we encounter some of the most mysterious and awe-inspiring creatures that ever lived. The ancient oceans were home to marine reptiles that dwarf even the largest whales of today. These weren't dinosaurs, despite what many people think, but entirely different groups of reptiles that returned to the sea and evolved into forms that seem almost alien to our modern eyes. The plesiosaurs represent one of the most successful adaptations to marine life ever achieved by reptiles. These creatures came in two basic body plans, each perfectly suited to their hunting style. The long-necked plesiosaurs, with necks that could contain up to 76 vertebrae, were like living periscopes. They could keep their massive bodies hidden in deeper water while extending their serpentine necks upward to ambush schools of fish near the surface. Some of these long-necked marine reptiles reached lengths of 40 feet or more, with necks that made up more than half their total body length. Swimming through ancient seas with their 4 large flippers, they moved with an underwater flight that was both graceful and eerily efficient. Their necks were incredibly flexible, able to strike like lightning at prey that thought it was safely out of reach. The short-necked plesiosaurs took a completely different approach to marine predation. These were the ocean's equivalent of modern orcas, powerful hunters with massive heads filled with teeth designed for grabbing and crushing large prey. Leedsichthys, one of the largest bony fish that ever lived, and even smaller marine reptiles would have been on the menu for these apex predators. Perhaps the most famous of the short-necked variety was Predator X, later named Pliosaurus funke. This marine monster possessed a skull over 6 feet long, filled with teeth the size of bananas. Its bite force has been estimated at over 33,000 pounds per square inch, more than enough to crush the bones of any creature unfortunate enough to end up in its jaws. What makes these ancient marine reptiles particularly fascinating is how they gave birth. Unlike most reptiles which lay eggs on land, plesiosaurs gave birth to live young in the water. Fossil evidence shows mothers with single large offspring, suggesting they invested heavily in each baby rather than producing many smaller young. This parental investment strategy is similar to what we see in modern whales and dolphins. The extinction of these marine giants at the end of the Cretaceous period left the oceans temporarily empty of large predators. It would be millions of years before whales evolved to fill these ecological niches. And even today's largest marine predators pale in comparison to some of these ancient sea monsters. As our journey through time continues, we encounter flying reptiles that ruled the skies long before birds took to the air. The pterosaurs were not dinosaurs, despite often being grouped with them in popular culture. They were the first vertebrates to achieve powered flight, developing this ability independently from birds and bats. The diversity of pterosaurs is truly remarkable. Some were as small as sparrows, delicate creatures that flitted through Mesozoic forests, catching insects on the wing. Others grew to absolutely massive proportions that challenge our understanding of how large a flying animal can be. Quetzalcoatlus, one of the largest pterosaurs ever discovered, had a wingspan that reached nearly 40 feet across. Imagine encountering such a creature in life. Standing on the ground, Quetzalcoatlus would have been as tall as a giraffe, with a head the size of a small car. Its neck alone was longer than the entire body of most modern birds. Yet, despite its enormous size, this flying giant was built with the hollow bones and air-filled spaces that made flight possible. These massive pterosaurs likely spent much of their time soaring on thermal updrafts, using their enormous wings to ride air currents with minimal energy expenditure. Like modern vultures, they may have been scavengers, using their keen eyesight to spot carrion from great distances. Their long, toothless beaks were perfect for reaching into carcasses, while their size would have intimidated smaller scavengers away from prime feeding spots. The smaller pterosaurs were no less remarkable in their own way. Some developed elaborate head crests that served as display structures, colorful advertisements of their fitness to potential mates. Others evolved specialized feeding strategies, with some becoming fish eaters with pelican-like throat pouches, while others developed teeth perfectly suited for crushing shellfish. The extinction of pterosaurs at the end of the Cretaceous period marked the end of an evolutionary experiment that had lasted over 150 million years. Birds, which had evolved alongside pterosaurs during the Mesozoic era, inherited the skies and diversified into the incredible variety of flying creatures we see today. But not all extinct flying animals were reptiles. During the Ice Age, the skies were ruled by birds so massive they could snatch prey as large as wolves and carry them away to mountaintop nests. Haast's eagle, which lived in New Zealand until just 600 years ago, was the largest eagle that ever lived, with females reaching weights of up to 37 pounds and wingspans of nearly 10 feet. This aerial giant evolved to hunt the moa, flightless birds that could stand 12 feet tall and weigh over 500 pounds. Haast's eagle would swoop down from great heights, striking these massive birds with talons the size of tiger claws. The impact alone was often enough to kill prey, with the eagle's momentum adding devastating force to its already formidable weapons. What makes Haast's eagle's story particularly poignant is how recently it vanished from our world. When Polynesian settlers arrived in New Zealand around 700 years ago, they hunted the moa to extinction within just a few centuries. Without its primary prey, Haast's eagle quickly followed the moa into oblivion, becoming extinct around 1400 CE. This pattern of recent extinctions tied to human activity becomes increasingly common as we move closer to the present day. The story of these lost creatures serves as both a window into Earth's incredible past and a reminder of how fragile the natural world can be. As you settle deeper into comfort tonight, let these images of ancient worlds drift through your mind. Picture vast Ice Age grasslands where mammoths trumpeted to each other across frozen valleys, their breath forming clouds in the frigid air. Imagine prehistoric seas where massive marine reptiles glided through crystal clear waters, their shadows passing over coral reefs filled with creatures unlike anything alive today. Our journey through the world of extinct animals has only just begun. There are countless more stories to tell, from the smallest prehistoric insects to the largest land animals that ever lived. Each creature represents millions of years of evolution, countless generations adapting and changing in response to an ever-shifting world. The next time you look at a modern animal, remember that it carries within its genes the echoes of all these ancient forms. Every bird flying overhead is a descendant of dinosaurs. Every whale in the ocean evolved from land mammals that once walked on 4 legs. The natural world around us is built upon the foundations laid by these extinct giants, their legacy written in the DNA of every living thing. Let these thoughts of deep time and evolutionary wonder carry you gently toward sleep, knowing that tomorrow we'll continue our exploration of the incredible creatures that once called Earth home. As the hours of night deepen around you, we venture further back in time to explore creatures that lived in worlds so different from our own that they might as well have existed on alien planets. These are the stories of animals that witnessed the birth of mountains, survived asteroid impacts, and adapted to climates that would be unrecognizable today. In the warm, humid forests of the Eocene epoch, 50 million years ago, our planet was a greenhouse world. Ice caps didn't exist at the poles, and tropical vegetation grew as far north as the Arctic Circle. Palm trees swayed in gentle breezes where glaciers now rest, and the ancestors of many modern animals were taking their first evolutionary steps toward the forms we recognize today. Among the most remarkable creatures of this ancient world was Ambulocetus, whose name literally means walking whale. This 4-legged predator represents one of evolution's most dramatic transformations, capturing a moment in time when whales were learning to swim. Picture an animal the size of a large seal, but with the elongated skull and teeth of a crocodile, paddling through shallow coastal waters with webbed feet. Ambulocetus still possessed 4 functional legs, but its limbs were already adapting for life in the water. Its hind feet were enormous and likely webbed, acting as natural flippers that propelled it through the water with undulating motions of its spine. On land, it would have moved with an awkward seal-like gait, but in the water, it was transformed into a graceful and deadly hunter. This ancient whale retained many features of its land-dwelling ancestors. Its nostrils were still positioned at the front of its snout, rather than on top of its head like modern whales. It had external ears and could probably hear well both in air and underwater. Most remarkably, it still possessed a full set of legs with ankles, knees, and even tiny hooves on its toes, evolutionary remnants of its terrestrial past. The transition from land to sea that Ambulocetus represents took place over millions of years, with each generation becoming slightly more aquatic than the last. Some of its descendants would eventually lose their hind limbs entirely, develop blowholes for breathing, and grow to the massive sizes we associate with modern whales. But Ambulocetus captures that magical moment of transformation when the ancestors of the largest animals on Earth were still taking their first tentative strokes into an aquatic future. Moving deeper into prehistoric time, we encounter the bizarre world of the Permian period, an era that ended with the greatest mass extinction in Earth's history. This was a time when our planet was dominated by creatures that seemed to blend characteristics of reptiles and mammals in ways that challenge our modern understanding of animal classification. Dimetrodon, with its spectacular sail-like back fin, stalked through ancient swamplands that would one day become the deserts of Texas and Oklahoma. Despite its reptilian appearance, this formidable predator was actually more closely related to mammals than to any modern reptile. Its distinctive sail, supported by elongated spinal vertebrae, likely served as a sophisticated temperature regulation system. In the cool morning hours, Dimetrodon would position its sail perpendicular to the sun's rays, using the large surface area to rapidly warm its blood. As temperatures rose throughout the day, it could angle the sail to minimize heat absorption or even use it as a radiator to cool down. This biological solar panel gave Dimetrodon a significant advantage over other predators of its time, allowing it to remain active when competitors were still sluggish from the cool night air. The teeth of Dimetrodon tell the story of a sophisticated predator. Unlike most reptiles, which have uniform peg-like teeth, Dimetrodon possessed differentiated dentition remarkably similar to modern mammals. Large canine teeth at the front of its jaws were perfect for delivering killing bites, while smaller teeth behind them could slice meat into manageable pieces. But Dimetrodon shared its Permian world with even stranger creatures. Helicoprion, the buzzsaw shark, patrolled ancient seas with one of the most bizarre feeding adaptations ever evolved. Its lower jaw extended into a spiral whirl of teeth that looked like a circular saw blade. For decades, paleontologists debated how this creature could possibly feed with such an unusual arrangement. Recent research suggests that Helicoprion used its tooth whirl like a combination of a buzz saw and a conveyor belt. As it opened its mouth, the spiral would unfurl, and as it closed its jaws, the rotating teeth would slice through the soft bodies of squid and other cephalopods. The older, worn teeth at the center of the spiral would be gradually pushed inward and eventually swallowed, while new, sharp teeth continuously grew at the outer edge. This remarkable shark survived for millions of years, indicating that its strange adaptation was highly successful in its ecological niche. Yet, like so many specialized predators, Helicoprion eventually succumbed to changing ocean conditions and the evolution of its prey species. The Permian period ended with the Great Dying, an extinction event so severe that it eliminated over 90% of all marine species and 70% of terrestrial vertebrates. The causes of this catastrophe are still debated, but massive volcanic eruptions in what is now Siberia likely played a major role, filling the atmosphere with toxic gases and dramatically altering the global climate. From the ashes of this devastation arose the age of dinosaurs, but not immediately. The Triassic period that followed was a time of recovery and experimentation, when life was tentatively exploring new evolutionary pathways. Among the most successful groups to emerge were the archosaurs, the ruling reptiles that would eventually give rise to both dinosaurs and crocodiles. Desmatosuchus was one of the most impressive archosaurs of the late Triassic, a heavily armored creature that looked like a cross between a crocodile and an armadillo. Growing up to 16 feet in length, it was covered from head to tail in thick, bony plates called osteoderms. These weren't just simple armor plates, but complex structures with ridges, spikes, and elaborate ornamentation that made Desmatosuchus look like a living fortress. Despite its fearsome appearance, Desmatosuchus was actually a plant eater, using its pig-like snout to root through soil and vegetation in search of roots, tubers, and other plant matter. Its teeth were small and leaf-shaped, perfect for processing plant material, but useless for hunting prey. The heavy armor was purely defensive, protection against the numerous predators that shared its Triassic world. The success of armored archosaurs like Desmatosuchus demonstrates an important principle in evolution. Sometimes the best defense is simply being too difficult to eat. While other animals invested in speed, intelligence, or camouflage to avoid predators, Desmatosuchus chose the straightforward approach of making itself virtually invulnerable to attack. But the Triassic world was also home to some of the earliest dinosaurs, small, agile creatures that were just beginning to explore the evolutionary pathways that would eventually lead to giants like Tyrannosaurus and Triceratops. Coelophysis, one of the best-known early dinosaurs, was a slender, bipedal predator, about the size of a large dog. Its lightweight build and long legs made it incredibly fast and maneuverable, allowing it to chase down small prey through the dense forests of the late Triassic. What's remarkable about Coelophysis is how clearly it displays the fundamental dinosaur body plan that would be refined and elaborated over the next 165 million years. Its hollow bones reduced weight without sacrificing strength, while its long tail provided balance and stability during high-speed pursuits. The arrangement of its hip bones defined it as a Saurischian dinosaur, placing it on the evolutionary line that would eventually lead to the mighty sauropods and fearsome theropods. Fossil evidence suggests that Coelophysis lived in large groups, perhaps hunting cooperatively like modern wolves or wild dogs. Some specimens have been found with the remains of smaller Coelophysis individuals in their stomach cavities, indicating that cannibalism may have been common during times of scarcity. This behavior, while disturbing to our modern sensibilities, is actually quite common in the animal kingdom and suggests that these early dinosaurs had complex social behaviors. As the Triassic period drew to a close, another mass extinction event cleared the way for dinosaurs to become the dominant land animals. This extinction, while not as severe as the Great Dying at the end of the Permian, eliminated many of the large archosaurs and other competitors that had been keeping dinosaurs in secondary ecological roles. The Jurassic period that followed is often considered the golden age of dinosaurs, a time when these remarkable reptiles diversified into an incredible array of forms. The long-necked sauropods reached sizes that seemed to defy the laws of physics, while armored ankylosaurs became living tanks that could shrug off attacks from the largest predators. Among the most fascinating of Jurassic dinosaurs was Carnotaurus, a predator so unusual that its name means meat-eating bull. This theropod possessed forward-facing horns above its eyes, giving it a demonic appearance that must have struck terror into the hearts of its prey. But Carnotaurus was built for speed rather than brute strength, with long, powerful legs that could carry it at speeds estimated to exceed 30 miles per hour. The arms of Carnotaurus were so reduced that they make the tiny arms of Tyrannosaurus rex look proportionally enormous. These vestigial limbs had no elbows or wrists, and ended in small, fingerless stumps that served no apparent function. It's a reminder that evolution doesn't always move toward greater complexity. Sometimes the best solution is to eliminate structures that are no longer needed. The skull of Carnotaurus was remarkably narrow when viewed from the front, with eyes that faced more forward than in most theropods. This binocular vision would have given it excellent depth perception, crucial for a high-speed predator that needed to judge distances accurately while pursuing fleeing prey through dense vegetation. Carnotaurus shared its South American habitat with some of the largest dinosaurs ever discovered. Argentinosaurus, a massive sauropod that may have weighed as much as 100 tons, wandered through the forests and floodplains of Cretaceous Argentina. To put this size in perspective, a single vertebra from Argentinosaurus is taller than a human being, and its thigh bone alone weighs more than a small car. The sheer scale of these creatures challenges our understanding of how large land animals can become. The heart of Argentinosaurus would have been enormous, pumping blood up its incredibly long neck to reach its head nearly 60 feet above the ground. The blood pressure required for this feat would have been tremendous, and the animal's entire cardiovascular system would have been adapted to handle these extreme demands. Yet, despite their massive size, sauropods like Argentinosaurus were surprisingly graceful animals. Their long tails served as counterbalances to their extended necks, and their pillar-like legs were positioned directly beneath their bodies for maximum support. Computer models suggest that they could move at a brisk walking pace, covering vast distances in search of the enormous quantities of vegetation they needed to sustain their bulk. The relationship between these giant herbivores and their predators represents one of nature's ultimate arms races. As plant eaters grew larger and more heavily defended, carnivores evolved greater size and more powerful weapons. This evolutionary dance reached its climax in the final period of the dinosaur age, when the largest land predators in Earth's history stalked prey that included some of the most heavily armored animals ever to walk the planet. Giganotosaurus, one of the largest theropod dinosaurs ever discovered, was perfectly equipped to hunt the massive sauropods of Cretaceous South America. At over 40 feet in length and weighing as much as 8 tons, it was even larger than the famous Tyrannosaurus rex. Its skull alone was over 5 feet long, filled with serrated teeth that could slice through flesh and bone with devastating efficiency. Unlike Tyrannosaurus, which had relatively small arms, Giganotosaurus possessed robust forelimbs with large curved claws that could have been used to grapple with prey. Its build suggests a more active hunting style, perhaps working in coordinated groups to bring down the enormous sauropods that shared its habitat. The idea of pack-hunting giant theropods is both fascinating and terrifying. Imagine a group of these massive predators working together to separate a young sauropod from its herd, using coordinated attacks to bring down prey that no single predator could hope to kill alone. The intelligence and social cooperation required for such behavior would have been remarkable, suggesting that some dinosaurs possessed far more complex cognitive abilities than previously believed. But the age of dinosaurs was drawing to a close. 66 million years ago, a massive asteroid slammed into the Earth near what is now the Yucatan Peninsula of Mexico. The impact released energy equivalent to billions of nuclear weapons, instantly vaporizing rock and sending massive amounts of debris into the atmosphere. The resulting darkness and climate change proved fatal to non-avian dinosaurs, ending their 165 million year reign as Earth's dominant land animals. Yet the story of dinosaurs didn't truly end with that cosmic catastrophe. Birds, which had evolved from small theropod dinosaurs during the Jurassic period, survived the extinction and went on to become one of the most successful groups of animals on the planet. In a very real sense, dinosaurs are still with us today, greeting each dawn with songs and taking to the air on wings that first evolved in the forests of the Mesozoic. The extinction of non-avian dinosaurs opened up ecological niches that would soon be filled by mammals, creatures that had spent the entire age of dinosaurs as small, largely nocturnal animals living in the shadows of their giant reptilian contemporaries. The mammals that inherited the Earth were about to embark on their own spectacular evolutionary radiation, giving rise to forms just as remarkable and diverse as the dinosaurs they replaced. As these thoughts of deep time and evolutionary change wash over you, allow your mind to drift with the gentle rhythm of prehistoric seas and the whisper of ancient winds through long vanished forests. The creatures we've encountered tonight lived in worlds separated by millions of years, yet they're all connected by the unbroken chain of life that links every organism that has ever existed on our planet. Rest now in the knowledge that tomorrow we'll continue our journey through these lost worlds, meeting more of the extraordinary animals that once called Earth home. Let the stories of their lives and adaptations carry you gently into dreams of ancient landscapes and forgotten kingdoms of life. The dawn of the age of mammals brought with it creatures that would reshape the very landscape of life on Earth. As the dust settled from the great extinction that ended the dinosaurs, small furry survivors emerged from burrows and tree hollows to inherit a world suddenly empty of its former giants. These humble beginnings would give rise to some of the most spectacular animals our planet has ever known. In the warm forests of the Paleocene epoch, just a few million years after the dinosaurs disappeared, early mammals were already experimenting with sizes and lifestyles that their ancestors could never have imagined. Barra lambda, one of the first truly large mammals, wandered through dense woodlands on legs like tree trunks, its massive claws designed for digging up roots and tubers from the rich forest soil. This ancient giant weighed nearly a ton, making it one of the largest land mammals of its time. Yet, despite its impressive bulk, Barra lambda was a gentle herbivore, spending its days peacefully foraging through vegetation that grew in the humid greenhouse climate of early Paleocene Earth. Its teeth were perfectly adapted for grinding tough plant material, while its powerful shoulders and arms gave it the strength to tear apart fallen logs in search of nutritious fungi and insects. What makes Barra lambda particularly fascinating is how quickly mammals were able to evolve large body sizes after the extinction of dinosaurs. Within just a few million years, creatures that had been limited to the size of small rodents during the Mesozoic era were growing to proportions that rivaled some of the smaller dinosaurs. It was as if life itself was eager to fill the empty ecological niches left behind by the great reptiles. But not all early mammals chose the path of gentle gigantism. In the forests and grasslands of the Eocene epoch, a group of mammals was developing into some of the most formidable predators the world had ever seen. These were the creodonts, ancient carnivores that dominated terrestrial ecosystems for over 30 million years before being replaced by the ancestors of modern cats, dogs, and bears. Sarcastodon was perhaps the most impressive of these prehistoric predators, a bear-like creature that stood 6 feet tall at the shoulder and possessed jaws capable of crushing bones with ease. Its skull alone was over 2 feet long, filled with teeth that combined the slicing ability of a cat's fangs with the bone-crushing power of a hyena's molars. This formidable predator ruled the forests of ancient Asia, hunting everything from early horses to primitive elephants. The lifestyle of Sarcastodon would have been similar to that of modern bears, but with a much more carnivorous diet. It likely spent much of its time following herds of herbivorous mammals, picking off the weak, young, and injured with devastating efficiency. Its powerful build suggests it was also capable of scavenging, using its massive jaws to break open bones that other predators couldn't access, extracting the nutritious marrow within. What's remarkable about creodonts like Sarcastodon is how different their evolutionary path was from modern carnivores. While cats and dogs evolved from a common ancestor and share many fundamental similarities in their hunting strategies, creodonts represented a completely independent experiment in mammalian predation. Their success for millions of years proves that there are many different ways to be an effective carnivore. The extinction of creodonts around 30 million years ago coincided with significant climate changes that transformed the lush forests of the Eocene into the more open grasslands of the Oligocene epoch. As dense woodlands gave way to savannas and prairies, the hunting strategies that had made creodonts so successful became less effective. The ancestors of modern carnivores, with their greater speed and agility, were better suited to hunting in these new, more open environments. This transition to grassland ecosystems would prove to be one of the most important developments in mammalian evolution. As forests retreated and vast prairies expanded across the continents, herbivorous mammals faced new challenges and opportunities. The abundant grasses provided a rich food source, but the lack of trees and dense vegetation meant that animals had fewer places to hide from predators. The response to these changing conditions was remarkable. Horses which had begun the Cenozoic era as small forest-dwelling creatures about the size of dogs, began a dramatic evolutionary transformation. Mesohippus, a three-toed ancestor of modern horses, stood about 2 feet tall and lived in the transitional forests and woodlands of the Oligocene. Its teeth were still adapted for browsing on soft leaves and shoots, but changes were already beginning that would eventually lead to the magnificent runners we know today. Over millions of years, horses gradually increased in size while their limbs became longer and more specialized for running. Their multiple toes slowly fused together, concentrating the animal's weight on a single, sturdy digit that could strike the ground with maximum efficiency. Most remarkably, their teeth underwent a complete transformation, developing the high-crowned, continuously growing molars needed to process the tough silica-rich grasses that became their primary food source. This evolutionary journey from forest browser to plains runner took place over tens of millions of years, with each generation slightly better adapted to life in the expanding grasslands. The fossil record of horse evolution is so complete that it provides one of the best examples we have of gradual evolutionary change, showing how environmental pressures can slowly but dramatically reshape an entire lineage. But horses weren't the only mammals adapting to life on the grasslands. The proboscideans, ancestors of modern elephants, were embarking on their own remarkable evolutionary journey. Moratherium, one of the earliest members of this group, looked nothing like a modern elephant. About the size of a pig, it lived in and around the rivers and swamps of ancient Egypt, using its slightly elongated snout to probe for aquatic vegetation. From these humble beginnings would emerge some of the most spectacular mammals ever to walk the earth. Dinotherium, whose name means terrible beast, stood 13 feet tall at the shoulder and possessed downward curving tusks that protruded from its lower jaw like massive pickaxes. These unusual tusks were probably used for stripping bark from trees and digging up roots, giving Dinotherium access to food sources that other herbivores couldn't reach. The evolutionary success of proboscideans led to an incredible diversity of forms. Some, like the shovel-tusked mastodon and mebelodon, developed flattened lower tusks that worked like bulldozer blades, perfect for scooping up soft aquatic plants from river bottoms. Others, like the four-tusked Gomphotherium, possessed both upper and lower tusks that could be used like massive hedge clippers to process tough vegetation. Perhaps the most bizarre of all proboscideans was Platybelodon, whose name means flat spear tooth. This strange creature possessed a lower jaw that extended into a broad, flat shovel lined with small teeth. Recent research suggests that Platybelodon used this remarkable adaptation to strip soft vegetation from tree branches, holding twigs and shoots against the flat surface while scraping away the nutritious parts with its specialized teeth. The diversity of proboscidean trunk and tusk adaptations rivals anything seen in modern mammals. Some species developed trunks that were relatively short and simple, while others evolved the incredibly sophisticated muscular appendages we see in modern elephants. The trunk of an elephant contains over 40,000 individual muscle fascicles, making it one of the most versatile tools in the animal kingdom. These ancient elephants shared their grassland and woodland habitats with an equally diverse array of other large mammals. The rhinoceros family, which today is represented by just 5 species, once included dozens of different forms adapted to every conceivable ecological niche. Prehistoric, the largest land mammal that ever lived, stood 18 feet tall at the shoulder and weighed as much as 4 modern elephants. This colossal herbivore was built like a living skyscraper, with legs like pillars and a neck long enough to browse on treetops that other animals couldn't reach. Unlike modern rhinos, Prehistoric had no horn, relying instead on its enormous size for protection from predators. Its teeth were perfectly adapted for processing leaves and soft shoots, indicating that it filled an ecological role similar to that of a modern giraffe, but on a scale that dwarfs any animal alive today. The sheer size of Prehistoric raises fascinating questions about the limits of mammalian gigantism. How did such an enormous animal support its own weight? How much food did it need to consume each day to fuel its massive metabolism? Computer models suggest that an adult Prehistoric would have needed to consume over 1,000 pounds of vegetation daily, spending most of its waking hours simply eating. The extinction of these giant mammals around 30 million years ago coincided with global cooling and the expansion of more seasonal climates. As the warm, stable conditions of the early Cenozoic gave way to the more variable climate patterns of the later Tertiary, many of the largest mammals found themselves unable to adapt to the changing conditions. Yet even as some lineages disappeared, others were just beginning their rise to prominence. The carnivores that would eventually give rise to modern cats, dogs, and bears were diversifying rapidly, developing the sophisticated hunting strategies and social behaviors that would make them some of the most successful predators in mammalian history. Amphibian, known as the bear dog, exemplified the experimental nature of early carnivore evolution. This powerful predator combined the robust build of a bear with the running ability of a large dog, creating a hunting machine perfectly adapted to the mixed woodland and grassland environments of the Miocene epoch. Standing 4 feet tall at the shoulder and weighing up to 600 pounds, Amphibian was capable of both powerful sprints and sustained pursuit of prey. The social behavior of these ancient carnivores is largely unknown, but their bone structure and tooth wear patterns suggest that some species may have hunted in coordinated packs. The ability to work together to bring down large prey would have been a significant advantage in a world filled with massive herbivores that no single predator could hope to tackle alone. As the Miocene epoch progressed, the climate continued to cool and dry, leading to the expansion of grasslands and the retreat of forests across much of the world. This environmental change favored fast-running animals that could cover large distances in search of food and water, while making life increasingly difficult for the forest-adapted giants of earlier epochs. The horses of this period were becoming increasingly modern in appearance, with species like Merychippus showing the high-crowned teeth and single-toed feet that would characterize all later horses. These animals lived in large herds that migrated across the vast grasslands of North America following the seasonal growth of grasses and avoiding the increasingly sophisticated predators that hunted them. But perhaps the most remarkable mammals of the Miocene were the early whales that were completing their transformation from land-dwelling carnivores to the ocean giants we know today. Basilosaurus, despite its serpentine name, was actually a fully aquatic whale that reached lengths of over 60 feet. Its hind limbs had been reduced to tiny vestiges that served no locomotory function, while its powerful tail and streamlined body made it a supremely efficient swimmer. The skull of Basilosaurus reveals the remarkable changes that occurred as whales adapted to life in the water. Its nostrils had moved from the tip of its snout to the top of its head, forming a primitive blowhole that allowed it to breathe without lifting its entire head above the surface. Its teeth, while still differentiated like those of terrestrial mammals, were perfectly adapted for grasping slippery fish and squid. What's most remarkable about early whales like Basilosaurus is how quickly they achieved such sophisticated adaptations to marine life. In less than 20 million years, the ancestors of whales had transformed from small, wolf-like carnivores into some of the largest animals ever to inhabit the oceans. This rapid evolutionary transformation ranks among the most dramatic examples of adaptive radiation in the entire fossil record. The success of early whales was made possible by the abundance of marine life in the warm oceans of the Eocene and Oligocene epochs. Ancient seas teemed with fish, squid, and marine reptiles that provided ample prey for these newly aquatic mammals. The lack of large marine predators following the extinction of the giant marine reptiles at the end of the Cretaceous meant that whales faced little competition as they diversified into various ecological niches. As we drift deeper into the night, these images of ancient grasslands and prehistoric seas begin to blur together like memories from a half-remembered dream. Picture vast herds of three-toed horses thundering across endless prairies, their hoofbeats creating rhythms that echo through millions of years. Imagine the splash of an early whale as it surfaces in a warm tropical sea, its primitive blowhole drawing breath from air that humans would not breathe for tens of millions of years. The mammals that inherited the post-dinosaur world faced challenges and opportunities that shaped not only their own evolution, but the very structure of modern ecosystems. Every adaptation, every extinction, every evolutionary success and failure contributed to the complex web of life that surrounds us today. The grass beneath our feet carries within its genes the memory of those ancient prairies. The songs of modern whales echo melodies first sung by their primitive ancestors in long-vanished oceans. These connections across deep time remind us that we are not separate from the natural world, but part of an unbroken chain of life that stretches back to the very beginnings of complex organisms on Earth. As you settle into the comfort of sleep, let these thoughts of continuity and connection carry you gently into dreams of ancient worlds where giants walked and swam and soared through skies that knew no human footprint. The stories of these remarkable creatures continue to unfold in fossil discoveries around the world, each new find adding another piece to the vast puzzle of life's history on Earth. Tomorrow, We'll venture even further into this magnificent past, exploring creatures so strange and wonderful that they challenge our very understanding of what it means to be alive on this ever-changing planet. In the gentle darkness of night, surrounded by the quiet breathing of a sleeping world, we can almost hear the distant echoes of those ancient voices calling across the vast expanses of time. They remind us that we are temporary custodians of a legacy that stretches back hundreds of millions of years, carriers of genetic memories that connect us to every creature that has ever lived. Let these profound connections guide you into peaceful rest, knowing that the story of life continues to unfold around us every day, written in the flight of birds that descended from dinosaurs, in the songs of whales that evolved from land mammals, and in our own existence as conscious beings capable of contemplating the magnificent history of life on Earth. As we continue our nocturnal journey through the corridors of deep time, we find ourselves drawn to more recent chapters in Earth's story, where the line between myth and reality becomes beautifully blurred. These are tales of creatures that walked among landscapes not entirely unlike our own, yet populated by animals so extraordinary that they seem borrowed from the pages of fantasy novels. The Pleistocene epoch, beginning roughly 2.5 million years ago, ushered in an age of giants that would persist until surprisingly recent times. This was the world of the great ice ages, when massive glaciers advanced and retreated across continents in slow, grinding cycles that reshaped the very face of our planet. Yet, between these frozen frontiers lay vast grasslands and forests, teeming with life on a scale that modern ecosystems can barely hint at. Imagine standing on a hilltop overlooking the Great Plains of North America 20,000 years ago. The landscape stretches endlessly before you, but instead of the familiar cattle and horses of today, massive forms move slowly across the grasslands like living mountains. These are the American mastodons, relatives of modern elephants that stood nearly 10 feet tall and weighed as much as 5 tons. Their curved tusks gleamed in the sunlight as they used them to strip bark from trees and dig through snow to reach buried vegetation. The mastodon's relationship with its environment was one of gentle transformation. Unlike their mammoth cousins, who were primarily grazers of open grasslands, mastodons were browsers that preferred the edges of forests and woodland clearings. Their teeth were perfectly designed for crushing twigs, leaves, and woody plant material, while their flexible trunks could delicately select the most nutritious parts of each plant. What made mastodons particularly remarkable was their ability to modify their habitat to suit their needs. Like modern elephants, they would push over trees to reach higher foliage, creating clearings that benefited countless other species. Their trails through dense forests became highways for smaller animals, while the wallows they created became seasonal ponds that supported diverse communities of amphibians, insects, and aquatic plants. The social structure of mastodon herds likely mirrored that of modern elephants, with matriarchal groups led by the oldest and most experienced females. These wise matriarchs carried within their memories the locations of seasonal food sources, water holes, and safe passage routes across dangerous terrain. Their knowledge, accumulated over decades of wandering through vast territories, was essential for the survival of entire family groups. But mastodons shared their North American homeland with predators that would have tested even these giants' defensive capabilities. The American lion, known scientifically as Panthera atrox, was 25% larger than any modern lion and possessed the strength to bring down prey as large as bison and young mastodons. These magnificent cats stalked through the grasslands and open woodlands, their tawny coats providing perfect camouflage among the golden grasses of the Pleistocene prairies. The hunting strategy of American lions likely differed significantly from their modern African cousins. Living in an environment rich with megafauna, they could afford to be more selective in their prey choices, focusing on the most vulnerable individuals in herds of massive herbivores. Their powerful build suggests they were ambush predators, using stealth and explosive strength rather than endurance to overwhelm their quarry. Even more formidable than the American lion was the short-faced bear, Arctodus simus, a predator so large and powerful that it may have forced other carnivores to abandon their kills simply through intimidation. Standing 12 feet tall on its hind legs and weighing up to 2,000 pounds, this massive bear was built more like a giant hyena than any modern Ursine. Its long legs and lean build suggest it was capable of surprising speed despite its enormous size. The skull of the short-faced bear reveals adaptations for a highly carnivorous lifestyle. Its massive jaw muscles could deliver bone-crushing bites, while its teeth were designed for slicing meat rather than grinding plant material like modern bears. This suggests that Arctodus was primarily a hunter and scavenger, rather than the omnivorous forager we associate with contemporary bear species. The extinction of the short-faced bear around 11,000 years ago coincided with the disappearance of many large Ice Age mammals. As the massive herbivores that formed the base of Pleistocene food webs vanished, specialized predators like Arctodus found themselves without adequate prey. The smaller, more adaptable black and brown bears that survived to the present day succeeded because they could switch between hunting, scavenging, and plant eating as conditions demanded. Moving south from the frozen grasslands of North America, we encounter the remarkable fauna of Ice Age South America, a continent that had been isolated from the rest of the world for millions of years. This isolation had allowed for the evolution of some of the most bizarre and wonderful creatures ever to walk the earth, animals so strange that early European explorers dismissed reports of them as tall tales and native mythology. Glyptodon was perhaps the most armored animal that ever lived, a creature that looked like a Volkswagen Beetle, covered in a shell of interlocking bony plates. These massive relatives of modern armadillos grew to the size of small cars, with some species reaching lengths of over 10 feet and weights exceeding 2 tons. Their shells, or carapaces, were marvels of natural engineering, providing complete protection from predators while still allowing the animal to move with surprising grace. The tail of Glyptodon was equally impressive, encased in rings of bone and ending in a massive club that could deliver devastating blows to any predator foolish enough to attack. Some species develop tail clubs with spikes and ridges that would have made medieval weapons seem primitive by comparison. The muscles required to swing such a massive weapon must have been enormous, making Glyptodon one of the few herbivores capable of actively fighting off even the largest predators. Despite their fearsome defensive capabilities, Glyptodonts were gentle giants that spent their days peacefully grazing on grasses and low-growing plants. Their teeth were perfectly adapted for grinding tough vegetation, while their powerful jaw muscles could process even the most fibrous plant material. They lived in small family groups, possibly defending territories around the best feeding areas, their massive shells glinting in the South American sun like living boulders. Sharing the pampas with Glyptodon were the giant ground sloths, creatures so large and powerful that they could rear up on their hind legs to reach vegetation 20 feet above the ground. Megatherium, the largest of these ancient sloths, weighed as much as 4 tons and possessed claws that were over a foot long. Yet, despite their formidable size and weapons, these gentle giants were strict vegetarians, using their massive claws to pull down tree branches and strip away bark. The lifestyle of giant ground sloths was probably similar to that of modern elephants, with individuals or small family groups wandering across vast territories in search of food. Their thick, shaggy coats would have provided insulation during the cool nights of the Ice Age, while their massive size helped them retain body heat during the day. Like many large herbivores, they likely had relatively slow metabolisms, allowing them to survive on vegetation that smaller animals would find insufficient. The relationship between giant ground sloths and their environment was one of mutual benefit. As they moved through forests and woodlands, pulling down branches and creating clearings, they opened up the canopy and allowed sunlight to reach smaller plants. Their dung provided fertilizer that enriched the soil, while their trails created pathways that other animals could follow through dense vegetation. But perhaps the most remarkable aspect of giant ground sloth biology was their longevity. These massive creatures may have lived for over a century, accumulating vast knowledge about their territories and the seasonal patterns of vegetation growth. Like modern elephants, the oldest individuals would have served as living libraries, their memories containing information crucial for the survival of their communities. The predators that shared South America with these armored giants had evolved their own unique adaptations. Smilodon populata, the largest of the saber-toothed cats, was even more massive than its North American relatives, with some individuals weighing over 800 pounds. This South American giant possessed the most robust build of any cat that ever lived, with incredibly powerful forelimbs designed for wrestling with prey many times larger than itself. The hunting strategy of Smilodon populata likely involved ambushing young or weakened giant ground sloths and glyptodonts, using its tremendous strength to knock them off balance before delivering a precise killing bite. The massive jaw muscles and specialized skull structure of this predator were perfectly adapted for delivering the controlled bite force necessary to penetrate the thick hide and neck muscles of megafaunal prey. What's particularly fascinating about South American Smilodon is evidence suggesting they may have lived and hunted in family groups. Fossil sites have yielded multiple individuals of different ages, indicating that these powerful predators may have cooperated in bringing down the largest herbivores of their time. The idea of coordinated saber-toothed cat packs hunting giant ground sloths adds an element of complexity to Ice Age ecosystems that rivals anything seen in the modern world. The extinction of South America's megafauna around 10,000 years ago marked the end of one of evolution's most spectacular experiments. The arrival of human hunters, combined with climate change at the end of the last ice age, proved fatal to creatures that had survived millions of years of environmental challenges. Within just a few thousand years, an entire world of giants vanished, leaving behind only fossils and the much smaller descendants of their more adaptable relatives. Yet some of these remarkable lineages managed to survive in reduced forms. The modern three-toed sloth, hanging languidly from branches in Central American rainforests, carries within its genes the memory of its giant ancestors. Similarly, the small armadillos that scurry through South American grasslands today are the diminished descendants of the mighty glyptodonts. Their shells still bearing the same basic pattern of protective plates that once made their ancestors nearly invulnerable. Moving across the ancient land bridges that connected continents during periods of low sea level, we encounter the remarkable fauna of Ice Age Australia, a continent populated by creatures so unusual that they challenge our understanding of mammalian possibilities. This was the realm of the marsupials, pouched mammals that had evolved in isolation for millions of years, developing forms and lifestyles that paralleled but never quite matched their placental cousins on other continents. Diprotodon, the largest marsupial that ever lived, wandered across the Australian landscape like a living haystack. Standing 6 feet tall at the shoulder and weighing as much as 3 tons, this massive wombat relative possessed continuously growing teeth that could process even the toughest vegetation. Its lifestyle was probably similar to that of a giant ground sloth, slowly moving from one feeding area to another while consuming enormous quantities of leaves, grasses, and shrubs. The pouch of Diprotodon must have been truly enormous, capable of carrying young that were themselves the size of large dogs. The maternal investment required to raise such massive offspring would have been tremendous, with mothers likely spending years caring for each baby. This long period of parental care would have allowed young diprotodonts to learn the complex knowledge needed to survive in Australia's challenging environment. But Diprotodon was just one member of a diverse community of giant marsupials that filled ecological niches occupied by very different animals on other continents. Procoptodon, the giant short-faced kangaroo, stood over 6 feet tall and possessed a skull and teeth adapted for browsing on leaves rather than grazing on grass like modern kangaroos. Its arms were proportionally much longer than those of any living kangaroo, possibly used for pulling down high branches or for defense against predators. The locomotion of Procoptodon was unlike that of any modern animal. While smaller kangaroos hop efficiently using both hind legs together, Procoptodon was probably too large for this energy-intensive form of movement. Instead, it likely walked on its hind legs like a giant bipedal browser, using its long arms for balance and support when reaching for food in trees and tall shrubs. The predators of Ice Age Australia were equally remarkable, including the largest marsupial carnivore that ever lived, Thylacoleo carnifex. The marsupial lion was built like no predator before or since, combining the powerful crushing jaws of a hyena with the climbing ability of a giant cat. Its most distinctive features were its massive premolar teeth, which functioned like bolt cutters, capable of shearing through bone and tough hide with devastating efficiency. Recent research suggests that Thylacoleo was an ambush predator that may have hunted from trees, dropping onto unsuspecting prey from above. Its powerful claws and muscular build would have allowed it to climb with ease despite its substantial size, while its unique dental adaptations gave it the ability to process prey that other predators couldn't handle effectively. The extinction of Australia's megafauna coincides closely with the arrival of human settlers around 50,000 years ago, suggesting that hunting pressure may have played a significant role in their disappearance. Unlike the megafauna of other continents, which had evolved alongside human ancestors for millions of years, Australia's giant marsupials had no experience with human predators and may have lacked the behavioral adaptations necessary to avoid them. The loss of these remarkable creatures represents one of the most dramatic ecosystem collapses in recent Earth history. Within just a few thousand years, Australia transformed from a continent dominated by giants to the land of smaller, more cryptic animals we know today. The ecological roles once filled by Diprotodon and its contemporaries remain largely empty, contributing to the unique character of modern Australian ecosystems. As we drift through these stories of vanished giants, the boundaries between different continents and time periods begin to blur like watercolors in the rain. Picture the vast grasslands of Pleistocene Eurasia, where herds of woolly rhinoceros moved like living tanks through landscapes that knew both bitter cold and surprising warmth. These magnificent creatures, covered in thick coats of russet brown fur, used their massive horns not for fighting, but for sweeping away snow to reach the nutritious grasses beneath. The woolly rhinoceros possessed adaptations that made it perfectly suited for life in the challenging environments of the Ice Age. Its broad, flat lips were ideal for grazing on the tough grasses and sedges that dominated the mammoth steppe, while its small ears and shortened tail minimized heat loss in frigid conditions. Most remarkably, its nasal passages were enlarged and lined with warming chambers that heated incoming air before it reached the lungs, preventing the respiratory problems that would plague tropical animals in such cold climates. These solitary giants carved out territories across the vast grasslands, following well-established migration routes between summer and winter feeding grounds. Their trails, worn deep by countless generations of use, became highways for other animals and remained visible in the landscape long after the last woolly rhinoceros had vanished. Like ancient roads leading to forgotten cities, these paths remind us of the complex behavioral patterns that once organized entire ecosystems. The cave paintings of early humans provide us with glimpses of these magnificent creatures as they appeared in life. Artists working by flickering firelight captured not just their physical appearance, but something of their character, showing woolly rhinoceros as powerful but peaceful inhabitants of a world where humans were still newcomers, learning to navigate landscapes shaped by millions of years of animal activity. But the Pleistocene world was also home to creatures that pushed the very limits of what we consider possible in mammalian design. The Irish elk, despite its name, was neither exclusively Irish nor technically an elk, but rather the largest deer that ever lived. Males possessed antlers that spanned 12 feet from tip to tip and weighed over 80 pounds. Massive structures that seemed to defy the basic principles of energy, efficiency, and survival. These enormous antlers were grown and shed annually, requiring tremendous amounts of calcium and other nutrients that had to be obtained from vegetation and stored in the deer's bones. The metabolic cost of producing such massive displays was enormous, yet the evolutionary benefits must have been equally significant. The size and complexity of a male's antlers served as honest advertisements of his genetic quality and nutritional status, allowing females to choose mates who could thrive despite carrying such seemingly impractical ornaments. The social behavior of Irish elk was probably similar to that of modern red deer, with males competing for access to harems of females during the autumn rutting season. The sight of two massive males clashing with their 12-foot antler spreads must have been one of the most spectacular displays in the natural world, a testament to the power of sexual selection to drive evolution in seemingly impossible directions. The extinction of the Irish elk around 7,000 years ago marked the end of one of evolution's most extravagant experiments. As forests replaced the open grasslands where these magnificent deer had thrived, their massive antlers became liabilities rather than assets, making it impossible for them to navigate through dense woodland vegetation. Climate change had literally reshaped their world in ways that their evolutionary specializations couldn't accommodate. In the warming oceans of the post-glacial world, marine ecosystems were undergoing their own dramatic transformations. The Caribbean monk seal, which survived until 1952, represents one of the most recent extinctions of a large marine mammal. These gentle pinnipeds lived in the warm, clear waters of the Caribbean, hauling out on sandy beaches to rest and give birth to their pups. Caribbean monk seals were perfectly adapted to life in tropical waters, lacking the thick blubber layer that characterizes their Arctic and Antarctic relatives. Instead, they relied on behavioral adaptations to regulate their body temperature, seeking shade during the hottest parts of the day and entering the water to cool off when necessary. Their streamlined bodies and powerful flippers made them graceful swimmers, capable of diving to considerable depths in search of fish and mollusks. The social structure of Caribbean monk seals was probably similar to that of modern Hawaiian monk seals, with females giving birth to single pups on secluded beaches after an 11-month gestation period. The bond between mother and pup was strong, with nursing continuing for several months, while the young seal learned the complex skills needed for independent survival in marine environments. The extinction of the Caribbean monk seal was entirely due to human activities, particularly hunting for oil and the disturbance of breeding beaches. by coastal development. Unlike many ice age extinctions, which involved complex interactions between climate change and human activity, the loss of this species can be traced directly to overhunting and habitat destruction. The last confirmed sighting was in 1952, making it one of the most recently extinct large mammals. The story of the Caribbean monk seal serves as a sobering reminder of how quickly human activities can drive even well-adapted species to extinction. These seals had survived the dramatic climate changes of the ice ages and the rising sea levels of the post-glacial period, only to be eliminated within a few centuries of intensive human contact. As these tales of recent extinctions weave through your consciousness like gentle waves lapping at the shore of sleep, consider the remarkable resilience that allowed so many species to survive millions of years of environmental change, only to succumb to challenges they had never encountered before. The mammoths that weathered dozens of glacial cycles, the giant ground sloths that adapted to countless shifts in vegetation patterns, the marsupial lions that survived Australia's transformation from forest to desert and back again. Each of these extinctions represents not just the loss of individual species, but the breaking of evolutionary relationships that had been millions of years in the making. When the last Caribbean monk seal died, it took with it countless generations of genetic wisdom about life in tropical seas. When the final Irish elk fell, the knowledge of how to grow and carry 12-foot antlers vanished forever from the world. Yet, in the gentle rhythm of your breathing tonight, in the steady beating of your heart, the story of life continues. Every cell in your body carries within it the molecular machinery that has been refined over billions of years of evolution. The same basic processes that powered the metabolism of woolly mammoths and giant ground sloths continue to fuel your own existence, connecting you across vast expanses of time to every creature that has ever lived. Let these thoughts of deep connection and evolutionary continuity carry you peacefully into sleep, knowing that tomorrow we will continue our exploration of the remarkable creatures that once shared our planet. In your dreams tonight, you might find yourself walking through Ice Age grasslands where giants still roam, or swimming in ancient seas where creatures of impossible beauty glide through crystal clear waters. The stories of these vanished worlds live on in the fossils buried beneath our feet, in the genetic codes of surviving species, and in the human imagination that allows us to reconstruct and appreciate the magnificent diversity of life that has graced our planet throughout its long and remarkable history. Rest flows through you now like ancient rivers carving their patient paths through stone, carrying whispers of creatures that once breathed the same air that fills your lungs tonight. As consciousness drifts toward sleep, we venture into realms where the familiar boundaries of size and possibility dissolve completely, revealing animals so extraordinary they seem conjured from the deepest wells of imagination. In the remote wilderness of the far north, where endless tundra stretches beneath skies that know both perpetual darkness and midnight sun, lived creatures whose very existence challenges our understanding of survival itself. These were landscapes of such brutal beauty that only the most perfectly adapted could call them home, yet they supported communities of life that thrived in conditions that would defeat most modern animals within hours. The cave bear emerges from these frozen chronicles as one of nature's most impressive experiments in ursine design. Standing nearly 12 feet tall on its hind legs and weighing close to a ton, this magnificent creature was built like a living fortress against the bitter cold of Ice Age Europe. Its massive skull, nearly twice the size of a modern grizzly, housed a brain that guided complex behaviors we're only beginning to understand through careful study of their ancient remains. What made cave bears truly remarkable wasn't just their size, but their sophisticated relationship with the landscape itself. These giants didn't simply endure the harsh winters of Pleistocene Europe. They transformed caves into elaborate seasonal homes, generation after generation, returning to the same underground chambers where their ancestors had sheltered. The floors of these caves became polished smooth by countless massive paws, while the walls bore the scratches of claws marking territory and perhaps even primitive forms of communication. The diet of cave bears represented one of evolution's more surprising turns. Despite their fearsome size and powerful build, these gentle giants were primarily vegetarian, using their massive jaws and specialized teeth to process tough plant materials that smaller animals couldn't digest. During the brief summer months, they would emerge from their caves to feast on grasses, roots, and berries, building up the enormous fat reserves needed to survive hibernation periods that could last up to 7 months. Their hibernation was itself a marvel of biological engineering. Unlike modern bears, which experience a lighter form of winter dormancy, cave bears entered states of suspended animation so profound that their metabolic rates dropped to barely detectable levels. In the deepest chambers of limestone caves, protected from the killing cold above, entire family groups would curl together in communal sleeping arrangements that conserved precious body heat through the endless winter nights. The social structure of cave bear communities was remarkably complex for such large carnivores. Evidence suggests they lived in extended family groups led by dominant females, much like modern elephants. These matriarchs possessed knowledge accumulated over decades of survival in one of Earth's most challenging environments. Understanding the subtle signs that indicated when winter was approaching and which caves offered the best protection from storms and predators. But even these perfectly adapted giants couldn't survive the dramatic changes that swept across Europe as the Ice Age drew to its close. As forests replaced the open grasslands where they had foraged for hundreds of thousands of years, cave bears found themselves trapped between changing climates above ground and the limited capacity of their underground refugees. The last of their kind disappeared around 24,000 years ago, leaving behind only the polished cave floors and scratch-marked walls that testified to their long residence in Europe's hidden places. Across the vast grasslands of ancient North America, another giant was writing its own chapter in the book of evolutionary experimentation. The American cheetah, known scientifically as Myricynonyx, represented nature's attempt to create the perfect pursuit predator for the wide open spaces of Pleistocene prairies. This remarkable cat combined the spotted coat and lean build of African cheetahs with adaptations uniquely suited to North American prey and terrain. Standing 3 feet tall at the shoulder and weighing nearly 200 pounds, the American cheetah was built for sustained high-speed chases across distances that would exhaust its African cousins. Its legs were proportionally longer and more robust, designed to maintain sprinting speeds over the rolling hills and broken terrain of the Great Plains. Most remarkably, its claws were only semi-retractile, creating natural running spikes that provided superior traction on grass and soft earth. The prey of American cheetahs included the swift pronghorn antelope, whose incredible speed evolved specifically as a response to these ancient predators. Even today, pronghorns can run at speeds exceeding 60 miles per hour, far faster than necessary to escape any modern predator. This seemingly excessive speed makes perfect sense when we realize that pronghorns are still running from ghosts, their bodies remembering predators that vanished 12,000 years ago. The hunting strategy of American cheetahs likely involved long-distance stalking, followed by explosive pursuit across open terrain. Unlike modern cougars, which are ambush predators adapted for broken country, these ancient cats were built for the patience and endurance required to run down prey across vast distances. Their enlarged hearts and lungs provided the cardiovascular capacity needed for sustained high-speed chases, while their lightweight bones reduced the energy cost of rapid acceleration. The extinction of American cheetahs coincided with the disappearance of many large North American herbivores at the end of the Pleistocene. As the vast herds of horses, camels, and pronghorns that had supported these specialized predators dwindled and disappeared, the cheetahs found themselves without adequate prey. Their highly specialized hunting adaptations, which had made them supremely successful for hundreds of thousands of years, became liabilities in a rapidly changing world. In the dense forests of Pleistocene Europe and Asia, a very different kind of predator was perfecting its own approach to survival. The cave lion, despite its name, was actually more closely related to modern tigers than to African lions, representing a distinct lineage that had adapted to life in the woodlands and grasslands of the northern continents. These magnificent cats grew to sizes that dwarfed any modern feline, with males reaching lengths of over 8 feet and weights approaching 700 pounds. The cave lion's hunting strategy was perfectly suited to the mixed woodland and grassland environments of Ice Age Eurasia. Unlike the pack-hunting behavior of modern African lions, these solitary predators relied on stealth, patience, and overwhelming power to bring down prey. Their massive canine teeth and incredibly strong jaw muscles allowed them to deliver killing bites that could penetrate the thick hides and heavy bones of Ice Age megafauna. What's particularly fascinating about cave lions is their relationship with early human populations. Cave paintings from across Europe depict these magnificent predators with remarkable accuracy, showing not just their physical appearance, but details of their behavior and social interactions. These ancient artists clearly observed cave lions closely, perhaps competing with them for the same cave systems that provided shelter during harsh winters. The coexistence of humans and cave lions represents one of the most dramatic predator relationships in human evolutionary history. Both species were apex predators, competing for similar resources, yet evidence suggests they may have occasionally benefited from each other's activities. Human hunters could have provided scavenging opportunities for lions, while the presence of these powerful cats may have helped keep other dangerous predators away from human settlements. The gradual extinction of cave lions around 14,000 years ago marked the end of one of the most successful feline lineages in evolutionary history. Climate change, habitat loss, and competition with increasingly sophisticated human hunters all contributed to their decline. Yet, their legacy lives on in the genetic code of modern cats and in the cave paintings that preserve their memory as symbols of wild power and untamed nature. Moving from the forests and grasslands to the ancient waterways, we encounter creatures that push the boundaries of freshwater gigantism to their absolute limits. The giant beaver, Casteroides ohioensis, inhabited the lakes and rivers of North America until just 10,000 years ago, representing nature's experiment with supersizing one of her most industrious mammals. These colossal rodents grew to the size of black bears, with some individuals reaching lengths of 8 feet and weights of over 400 pounds. Their massive incisors, nearly 6 inches long, were perfectly designed for felling trees that modern beavers couldn't even attempt to tackle. Unlike their smaller cousins, giant beavers likely didn't build the complex dam systems we associate with modern beaver engineering, instead creating simple burrows and riverbanks and lake shores. The lifestyle of giant beavers was probably more similar to that of modern capybaras than contemporary beavers, with these massive rodents spending much of their time in the water feeding on aquatic vegetation. Their webbed hind feet and powerful tails made them surprisingly graceful swimmers despite their enormous bulk, while their dense fur provided insulation in the cold waters of Pleistocene North America. The extinction of giant beavers coincides with the disappearance of the large shallow lakes that provided their preferred habitat. As the climate warmed at the end of the Ice Age, many of these water bodies dried up or were replaced by faster flowing rivers that didn't support the aquatic vegetation these gentle giants required. The surviving beaver populations, being smaller and more adaptable, were able to colonize new habitats and develop the dam building behaviors that make them such successful ecosystem engineers today. In the warm seas of the Cenozoic era, marine mammals were conducting their own experiments with size and feeding strategies that would make modern whales seem almost conventional by comparison. Leviathan melvillei, named after the author of Moby Dick, was a sperm whale with teeth the size of wine bottles and jaws powerful enough to crush other whales. This apex predator of ancient oceans grew to lengths of over 50 feet, rivaling the largest modern sperm whales, but with a fundamentally different approach to marine predation. Unlike modern sperm whales, which primarily feed on squid using suction feeding, Leviathan was an active hunter of large marine mammals. Its massive teeth were perfectly designed for grasping and crushing prey, while its reinforced skull could withstand the tremendous forces generated during attacks on other whales. This prehistoric leviathan likely hunted baleen whales, pinnipeds, and even other toothed whales, making it one of the most formidable marine predators that ever lived. The hunting strategy of Leviathan probably involved high-speed ramming attacks followed by sustained grappling with prey. Its powerful tail flukes could generate enormous propulsive force, while its massive head served as both weapon and shield during close quarters combat with other large marine animals. The brain of Leviathan was proportionally large, suggesting these ancient whales possessed the intelligence needed for complex hunting behaviors, and possibly even cooperative strategies. The extinction of Leviathan around 9 million years ago coincided with changes in ocean circulation and temperature that affected the distribution of their prey species. As the warm, productive seas of the Miocene gave way to cooler, more seasonal oceans, the large marine mammals that supported these apex predators became less abundant. Modern sperm whales succeeded where Leviathan failed by developing more flexible feeding strategies that could adapt to changing ocean conditions. The story of these vanished marine giants reminds us that the oceans have hosted predators far more formidable than anything alive today. The largest modern predatory whale, the orca, weighs less than 10 tons and feeds primarily on fish and smaller marine mammals. Leviathan was 5 times larger and capable of hunting prey that modern marine predators wouldn't dare approach. As these images of ancient oceans and vanished predators drift through your consciousness like bioluminescent plankton in dark waters, consider the remarkable diversity of solutions that evolution has found to the basic challenges of survival. Each extinct species represents millions of years of trial and error, countless small improvements and adaptations that gradually molded living creatures into forms perfectly suited to their particular corner of the natural world. The cave bears that polished limestone floors with their massive paws, the American cheetahs that raced across endless grasslands, the giant beavers that shaped entire watersheds with their engineering projects, all solved the puzzle of existence in their own unique ways. Their solutions worked perfectly for millions of years, allowing them to thrive in environments that would challenge any modern animal. Yet in the end, all of these remarkable adaptations proved insufficient when faced with the rapid changes that marked the transition from the Pleistocene to our modern world. The specialized tools that had made these creatures supremely successful in their ancient environments became limitations when those environments disappeared. It's a humbling reminder that even the most perfect adaptations are only perfect for specific conditions, and that the natural world is constantly changing in ways that can make yesterday's advantages tomorrow's disadvantages. The genetic legacy of these vanished giants lives on in their surviving relatives, carrying forward the molecular innovations that once powered some of Earth's most remarkable creatures. Modern bears still possess the genes that enabled their cave bear cousins to survive months of hibernation in frozen caves. Contemporary beavers retain the genetic toolkit that once built giant rodents capable of felling massive trees. Even modern house cats carry within their DNA the echoes of the mighty cave lions that once ruled the forests of Ice Age Europe. These connections across deep time remind us that extinction is not truly an ending, but a transformation, with the innovations of vanished species continuing to influence the evolutionary trajectories of their descendants. Every modern animal is built upon foundations laid by countless extinct ancestors, their genetic contributions woven into the fabric of contemporary life in ways both obvious and subtle. Let these thoughts of continuity and connection guide you gently toward sleep, knowing that the story of life continues to unfold around us every moment of every day. In the rustling of leaves outside your window, you might hear echoes of the forests where cave lions once hunted. In the splash of water in a nearby stream, you might sense the presence of the ancient waterways where giant beavers once engineered their simple but effective homes. The boundary between past and present becomes beautifully fluid in the realm of dreams, where time itself seems to flow backward and forward like tidal currents carrying messages between distant shores. Tonight, as consciousness fades into peaceful rest, you become part of that timeless flow, connected to every creature that has ever lived through the shared miracle of existence itself. Tomorrow, we will continue our journey through these lost worlds, exploring creatures even more remarkable and landscapes even more fantastic than those we've encountered tonight. But for now, rest in the knowledge that you are surrounded by the invisible presence of all life that has come before, their stories written in the very atoms that compose your sleeping form, their legacy continuing in every breath you take and every beat of your heart. In the gentle darkness that embraces you now, the ancient world comes alive with the soft footfalls of vanished giants, the whisper of extinct wings through prehistoric skies, and the eternal rhythm of waves that have been carrying the same life-giving molecules between sea and shore for billions of years. These are the lullabies of deep time, the songs that have been singing Earth to sleep and awakening her to new dawns since life first stirred in the primordial oceans. Sleep now, and dream of worlds where wonder walked on four legs, soared on feathered wings, and swam through seas that sparkled with possibilities we can barely imagine. The stories of these remarkable creatures will be waiting for you when you wake, ready to carry you once again into the magnificent tapestry of life that has been weaving itself across our planet for hundreds of millions of years. The gentle currents of sleep carry us now toward shores where reality and impossibility merge like morning mist over ancient landscapes. As your breathing deepens and consciousness begins its nightly journey into dreams, we drift back through corridors of time to witness some of nature's most audacious experiments in the art of living. In the shadowed depths of prehistoric seas, where sunlight filtered down through waters teeming with life forms that seem borrowed from alien worlds, enormous creatures moved with grace that defied their massive proportions. These were the marine reptiles of the Mesozoic era, animals so perfectly adapted to their aquatic realm that they make modern whales seem like recent newcomers to the ocean's embrace. The long-necked plesiosaurs glided through these ancient waters like living submarines, their serpentine necks extending 40 feet or more above bodies that remained hidden in the darker depth below. Picture these magnificent creatures as they hunted, their necks weaving through schools of primitive fish, with movements so fluid they seemed more like sea serpents from mythology than flesh and blood animals. Their four massive flippers beat in perfect synchronization, propelling them through the water with an underwater flight that was both mesmerizing and deadly. What made these marine giants truly remarkable was their hunting strategy, refined over millions of years of evolution. The longest-necked species could position their bodies deep underwater while extending their heads to the surface, creating the illusion of multiple separate creatures to schools of fish, feeding near the sunlit shallows. When prey ventured within range, the strike would come with lightning speed, those incredibly flexible necks snapping forward to engulf victims before they could react. The shorter-necked varieties took a completely different approach to marine predation. These were the ocean's equivalent of modern killer whales, but built on a scale that dwarfs anything alive today. Leadzictus, one of the largest bony fish that ever lived, would have been merely a snack for these apex predators, whose skulls alone measured over 6 feet in length and housed teeth the size of railroad spikes. These marine monsters possessed bite forces that could crush the bones of any creature unfortunate enough to end up between their jaws. Conservative estimates suggest they could exert over 30,000 pounds of pressure per square inch, more than enough to shatter the shells of the largest ammonites or penetrate the armored hides of other marine reptiles. Yet, despite their fearsome weaponry, these giants were surprisingly intelligent creatures, with brain-to-body ratios that suggest complex behaviors, and possibly even primitive forms of social organization. Evidence from fossil sites indicates that some plesiosaurs may have given birth to live young in the open ocean, a remarkable adaptation that allowed them to remain fully aquatic throughout their entire life cycle. The discovery of pregnant females with single, large offspring suggests these ancient reptiles invested heavily in each baby, much like modern whales and dolphins. This parental care strategy would have required sophisticated behaviors, with mothers likely teaching their young the complex skills needed to survive in the challenging environment of Mesozoic seas. The extinction of these marine giants at the end of the Cretaceous period left the oceans temporarily empty of large predators, creating an ecological vacuum that wouldn't be filled for millions of years. When mammals eventually returned to the sea and evolved into whales, they developed very different approaches to marine life, relying on echolocation and filter-feeding strategies rather than the visual hunting techniques that had made plesiosaurs so successful. Rising from these ancient waters to explore the skies above, we encounter flying reptiles that challenge our very understanding of what's possible in vertebrate flight. The pterosaurs were not dinosaurs, despite popular misconceptions, but represented an entirely separate lineage that achieved powered flight independently from both birds and bats. Their success in the air lasted over 150 million years, making them one of evolution's most enduring experiments in aerial locomotion. The smallest pterosaurs were delicate creatures no larger than sparrows, flitting through Mesozoic forests with gossamer wings that caught sunlight like stained glass windows. These tiny flyers possessed hollow bones so delicate they seem almost impossible, yet strong enough to support the complex flight muscles needed for powered flight. Their diet consisted primarily of insects, which they caught on the wing with precision that would impress modern aerial predators. At the opposite extreme were giants that seemed to defy the basic laws of aerodynamics. Quetzalcoatlus stood as tall as a giraffe when grounded, with wings that spanned nearly 40 feet from tip to tip. The engineering challenges involved in getting such a massive creature airborne were solved through innovations that modern aircraft designers can only admire. Every bone was hollow, filled with air spaces that reduced weight without sacrificing structural integrity. The wing membranes themselves were marvels of biological engineering, supported by a single elongated finger bone and reinforced with fibers that could withstand the tremendous stresses of flight. The lifestyle of these aerial giants remains one of paleontology's most intriguing puzzles. Some scientists believe they were primarily scavengers, using their enormous size to intimidate smaller competitors away from carcasses. Others suggest they were active predators, capable of snatching prey as large as small dinosaurs and carrying them to elevated feeding sites. Their long, toothless beaks were perfectly designed for reaching into carcasses or probing for hidden prey, while their keen eyesight allowed them to spot opportunities from great distances. The flight mechanics of giant pterosaurs required them to be master meteorologists, reading air currents and thermal patterns with an expertise that modern glider pilots spend years trying to develop. They likely spent hours soaring on rising air masses, covering vast distances with minimal energy expenditure. Like modern albatrosses, they may have been capable of remaining airborne for days at a time, touching down only when feeding opportunities or social interactions demanded it. The diversity of pterosaur feeding strategies was truly remarkable. Some species developed elaborate head crests that served as both display structures and possibly as aids to flight stability. Others evolved specialized teeth for crushing shellfish or catching fish, while still others became aerial filter feeders with pelican-like throat pouches for scooping up small prey from the ocean's surface. The extinction of pterosaurs at the end of the Cretaceous marked the end of one of evolution's most successful flying lineages. Birds, which had evolved alongside pterosaurs throughout the Mesozoic, inherited the skies and diversified into the incredible variety of aerial forms we see today. Yet, no bird has ever matched the sheer size and majesty of the largest pterosaurs, making these extinct giants unique in the history of vertebrate flight. Descending from the ancient skies to explore terrestrial realms, we encounter predators that combine the hunting prowess of modern big cats with specialization so extreme they seem almost fictional. The saber-toothed cats represent one of evolution's most dramatic experiments in predatory design, developing their distinctive weaponry multiple times in different lineages across millions of years. Smilodon, the most famous of these prehistoric predators, was built like a living battering ram rather than the sleek pursuit predator we might expect. Its front legs were incredibly muscular, designed not for running, but for wrestling with prey much larger than itself. The massive shoulders provided anchor points for muscles that could deliver devastating power, allowing these cats to pin down struggling victims while positioning themselves for the killing bite. Those iconic 7-inch fangs were actually quite fragile and had to be used with surgical precision. Rather than the slashing attacks we might imagine, Smilodon employed a careful, controlled bite that targeted the soft tissues of the throat or belly. The long canine teeth were perfectly shaped for penetrating between ribs or slipping past protective bones to reach vital organs. This hunting technique required incredible strength and patience, as the cat had to completely immobilize its prey before attempting the delicate killing bite. What's particularly fascinating about saber-toothed cats is how they evolved this specialized hunting technique repeatedly in different evolutionary lineages. The strategy was so effective for dealing with large, thick-skinned prey that natural selection kept returning to this solution. During the Ice Age, when massive ground sloths, ancient bison, and young mammoths provided abundant large prey, having the tools to bring down such formidable animals was a significant evolutionary advantage. The social behavior of some saber-toothed cats may have been far more complex than previously imagined. Fossil evidence from tar pits and bone caves suggests that some species lived and hunted in family groups, cooperating to bring down the largest herbivores of their time. The image of coordinated saber-toothed cat packs working together to hunt giant ground sloths adds a level of behavioral sophistication that rivals anything seen in modern predators. The extinction of saber-toothed cats coincides closely with the disappearance of the megafauna they specialized in hunting. As their preferred prey vanished, these highly specialized predators found themselves unable to adapt to a world of smaller, more agile animals. Modern cats succeeded where saber-tooths failed because they maintained the flexibility to hunt a wide variety of prey sizes and types. Moving from land predators to the realm of ancient herbivores, we encounter creatures that challenge the very limits of terrestrial gigantism. The sauropod dinosaurs achieved sizes that seemed to violate the basic laws of physics, yet they thrived for over 100 million years across every continent on Earth. These gentle giants represent perhaps evolution's most ambitious experiment in large-scale herbivory. Argentinosaurus, one of the largest sauropods ever discovered, may have weighed as much as 12 modern elephants combined. To visualize this scale, imagine a creature whose thigh bone alone weighed more than a small automobile, whose vertebrae stood taller than adult humans, and whose tail could level small trees with a casual sweep. Yet, despite their massive proportions, these animals were surprisingly graceful, moving across Cretaceous landscapes with a dignity that befitted their enormous size. The physiological challenges of being a sauropod were staggering. The heart required to pump blood up a neck that stretched 60 feet into the air would have been enormous, generating blood pressures that would be instantly fatal to any modern animal. The digestive system needed to process hundreds of pounds of vegetation daily, requiring a gut capacity that could accommodate the massive fermentation chambers needed to break down tough plant material. Most remarkably, sauropods accomplished all of this while maintaining body temperatures that allowed for active lifestyles. Recent research suggests they may have possessed metabolic rates intermediate between modern reptiles and mammals, giving them the energy needed for their enormous size while avoiding the impossible caloric requirements that full warm-bloodedness would have demanded. The social behavior of sauropods was likely complex, with evidence suggesting they lived in herds that migrated across vast distances following seasonal food sources. Trackway fossils show groups of different-sized individuals traveling together, with smaller juveniles protected in the center of the herd while larger adults formed defensive perimeters. These ancient migrations may have involved hundreds of individuals moving across landscapes in formations that stretched for miles. The long necks of sauropods served multiple functions beyond simply reaching high vegetation. They allowed these giants to browse across enormous areas without moving their massive bodies, conserving energy while maximizing food intake. Different species evolved necks specialized for different feeding strategies, with some designed for ground-level browsing, while others could reach treetops 40 feet above the ground. The extinction of sauropods in most parts of the world at the end of the Cretaceous marked the end of terrestrial gigantism on a scale never seen before or since. The largest modern herbivores, African elephants, weigh less than a tenth of what the biggest sauropods achieved. The ecological roles once filled by these gentle giants remain largely vacant, contributing to the relatively impoverished megafauna of modern terrestrial ecosystems. In the warm, shallow seas that covered much of the world during the Mesozoic era, marine reptiles were conducting their own experiments with predatory specialization. Mosasaurs, despite their serpentine appearance, were actually marine lizards that had adapted to life in the open ocean with remarkable success. These apex predators grew to lengths exceeding 50 feet, making them among the largest marine predators that ever lived. The skull of a large mosasaur was a masterpiece of predatory engineering, filled with rows of sharp teeth designed for grasping slippery prey. Unlike modern snakes, which can dislocate their jaws to swallow large prey whole, mosasaurs possessed rigid skulls that required them to dismember their victims before consumption. Their powerful neck muscles and flexible spines allowed them to thrash captured prey with devastating force, breaking bones and tearing flesh with movements that would have been visible from great distances. The swimming style of mosasaurs was unique among marine reptiles, relying on undulations of their massive tails, rather than the flipper-based propulsion used by plesiosaurs. This snake-like locomotion was incredibly efficient, allowing these predators to maintain high speeds over long distances while pursuing prey through the open ocean. Their streamlined bodies and powerful muscles made them the underwater equivalent of modern great white sharks, but built on a scale that dwarfs any modern marine predator. The diet of mosasaurs was remarkably diverse, ranging from fish and squid to other marine reptiles, and even smaller members of their own species. Fossil evidence shows bite marks on mosasaur bones that could only have been made by other mosasaurs, indicating that cannibalism was common among these apex predators. This behavior, while shocking to modern sensibilities, actually makes perfect ecological sense in an environment where the largest predators had few natural enemies other than each other. The extinction of mosasaurs at the end of the Cretaceous left the oceans without large marine reptile predators for the first time in over 100 million years. The ecological niches they occupied would eventually be filled by marine mammals, but it took millions of years for whales to evolve to sizes comparable to the largest mosasaurs. Even today, no marine predator matches the sheer size and power of these ancient sea monsters. As we drift deeper into the realm of dreams, where time flows like honey and the boundaries between possible and impossible dissolve completely, these images of vanished worlds begin to merge and blend like colors on an artist's palette. Picture yourself standing on the shore of a Cretaceous sea, watching as massive mosasaurs surface to breathe in waters that sparkle with an intensity unknown to modern oceans. Above you, pterosaurs with wingspans wider than school buses ride thermal currents that rise from landscapes carpeted with vegetation no human eye has ever seen. The air itself would have been different in these ancient worlds, richer in oxygen and filled with the calls of creatures that have no modern equivalents. The very ground beneath your feet would have trembled with the footsteps of sauropods whose passage marked time itself. Their migrations following routes established millions of years before the first human ancestor learned to walk upright. These vanished ecosystems operated according to rules that seem almost magical compared to the natural world we know today. Predators, the size of city buses, hunted prey that weighed as much as trucks, while flying reptiles larger than small aircraft soared through skies that knew no contrails or engine noise. The sheer scale of life in these ancient worlds challenges our understanding of what's possible within the constraints of biology and physics. Yet, for all their apparent impossibility, these creatures were perfectly real, breathing the same basic molecules that fill your lungs tonight, their hearts beating with the same fundamental rhythms that pulse through your sleeping form. They face the same basic challenges that confront all living things, finding food, avoiding predators, reproducing successfully, and adapting to changing environmental conditions. Their solutions to these universal problems were simply scaled up to proportions that modern life can barely comprehend. The genetic innovations that powered these ancient giants continue to influence life today in ways both obvious and subtle. The hollow bones that made pterosaur flight possible evolved into the pneumatic skeleton system that allows modern birds to achieve powered flight. The complex social behaviors of sauropod herds laid the groundwork for the sophisticated group dynamics we see in modern elephants and other large herbivores. Even the predatory strategies of saber-toothed cats find echoes in the hunting techniques of contemporary big cats. The extinction of these remarkable creatures at the end of the Mesozoic era marked one of the most dramatic transitions in Earth's history, but it wasn't truly an ending. The asteroid impact that ended the age of dinosaurs also opened new evolutionary pathways that led directly to the modern world we inhabit. The mammals that inherited the Earth carried within their genetic code the potential for their own experiments with gigantism, leading eventually to creatures like woolly mammoths, giant ground sloths, and cave bears. This ongoing cycle of innovation, success, and eventual replacement represents the fundamental rhythm of evolution itself. Each extinct species contributed something unique to the great experiment of life on Earth, their genetic innovations becoming part of the foundation upon which future species would build their own adaptations. Nothing is ever truly lost in the evolutionary process. It simply transforms into new possibilities and unexplored potentials as sleep draws you deeper into its gentle embrace. Let these thoughts of transformation and continuity carry you into dreams where ancient and modern merge in landscapes of impossible beauty. Tonight, in the theater of your unconscious mind, you might find yourself soaring alongside pterosaurs through Mesozoic skies, or swimming with plesiosaurs through seas that sparkled with bioluminescent life forms unknown to modern science. The stories of these vanished worlds live on not just in fossils and scientific reconstructions, but in the deeper patterns that continue to shape life on our planet. Every modern ecosystem is built upon foundations laid by countless extinct species, their influence woven into the fabric of contemporary life in ways both visible and hidden. The flight of a modern bird carries within it the memory of pterosaur wings, while the migration patterns of African elephants echo the ancient journeys of long-vanished proboscideans. Rest now in the knowledge that you are connected to this vast tapestry of life through bonds that stretch back hundreds of millions of years. The same basic biological processes that powered the mighty sauropods continue to fuel your own existence, while the genetic code that guides your development shares fundamental similarities with creatures that vanished long before humans ever walked the earth. Tomorrow, we will continue our exploration of these lost worlds, venturing into realms where even stranger creatures await our discovery. But for now, let the gentle rhythm of your breathing carry you into peaceful slumber, surrounded by the invisible presence of all the remarkable animals that have shared our planet throughout its long and magnificent history. In your dreams tonight, time itself becomes fluid, allowing you to witness the great transitions that have shaped our world. You might see the moment when the first pterosaur spread its wings and discovered the joy of flight, or watch as the earliest whales took their first tentative strokes into an aquatic future that would reshape their entire lineage. These are the dreams that connect us to our deepest origins, reminding us that we are all children of the same evolutionary process that created every creature that has ever lived. Sleep peacefully now, cradled by the knowledge that the story of life continues to unfold around us every moment, written in languages we are only beginning to learn how to read. The fossil record beneath our feet, the genetic codes within our cells, and the behavioral patterns of modern animals all carry messages from vanished worlds, ensuring that nothing truly remarkable is ever completely lost to time. The ancient giants sleep now in stone and memory, but their legacy lives on in every sunrise that illuminates a world still shaped by their long residence on our shared planet. Let their stories sing you gently into dreams where wonder walks on wings of possibility. and where the boundary between extinction and continuation reveals itself to be far more permeable than we ever dared imagine. In the hushed stillness that surrounds you now, where moonlight filters through curtains like silver threads weaving dreams, we venture into one final realm of vanished wonders. These are the stories of creatures that walked among landscapes so recently departed that their absence still echoes in the empty spaces they once filled. Animals whose existence overlapped with the earliest whispers of human civilization, yet whose form seemed drawn from the deepest wells of imagination. The great auks once gathered in colonies so vast they darkened the rocky shores of the North Atlantic, their sleek black and white forms creating living tapestries against granite cliffs that had witnessed the coming and going of ice ages. These flightless seabirds, standing nearly 3 feet tall, were the penguins of the northern hemisphere, perfectly adapted to life in the frigid waters where icebergs drifted like floating cathedrals and storms raged with primordial fury. What made great auks truly remarkable wasn't just their impressive size or their penguin-like appearance, but their mastery of the underwater realm. Their wings, useless for flight, had evolved into powerful underwater propulsion systems that could drive them through the water at speeds that left fish struggling to escape. Their streamlined bodies cut through ocean currents with an efficiency that modern submarines can only approximate, while their webbed feet served as both rudders and brakes. In the three-dimensional world beneath the waves, the social life of great auk colonies was a spectacle that defied description. During breeding season, hundreds of thousands of these magnificent birds would converge on isolated islands and sea stacks, their harsh calls creating a cacophony that could be heard for miles across open water. Each pair would claim a small territory on the rocky ledges, defending it with ritualized displays that involved elaborate head movements and synchronized calling that reinforced the bonds between mates. The single egg that each pair produced was a masterpiece of natural engineering, proportionally larger than almost any other bird egg, and perfectly adapted to the harsh conditions of North Atlantic breeding colonies. The parents would take turns incubating their precious cargo, one always remaining on guard, while the other ventured into the dangerous waters to hunt for the fish and marine invertebrates that sustained their growing chick. What's most heartbreaking about the great auk story is how recently these magnificent seabirds disappeared from our world. The last confirmed pair was killed on Eldey Island off the coast of Iceland in 1844. Their final moments witnessed by the very humans who had driven their species to extinction through centuries of relentless hunting. Unlike the mysterious disappearances that claimed so many Ice Age giants, the extinction of great auks was documented with tragic precision. Each colony's demise recorded as sailors and fishermen systematically eliminated one of the ocean's most spectacular inhabitants. The great auk's inability to fly, which had served them so well in their aquatic environment, became their fatal weakness when faced with human predators. Unable to escape to inaccessible nesting sites, they were helpless against hunters who valued them for their meat, eggs, and feathers. Their trusting nature evolved over millions of years in an environment where they faced few natural predators on land, made them easy targets for humans who saw them not as magnificent wildlife, but as resources to be harvested. Yet, even as we mourn the loss of these remarkable seabirds, their story reminds us of the incredible diversity that once characterized our planet's marine ecosystems. The great auk was just one member of a family of seabirds that had mastered life in some of Earth's most challenging environments, developing adaptations that allowed them to thrive in waters where other animals could barely survive. Moving from the icy waters of the North Atlantic to the lush forests of the Caribbean, we encounter another recent extinction that illustrates how quickly human activity can transform entire ecosystems. The Cuban giant beaver, despite its name, was not actually a beaver at all, but rather the largest rodent that survived into historical times. These remarkable creatures, weighing over 200 pounds, were the final representatives of a once diverse family of giant rodents that had dominated Caribbean islands for millions of years, standing 4 feet tall at the shoulder and stretching nearly 8 feet from nose to tail. Cuban giant beavers were built like living fortresses against the tropical storms and predators of their island home. Their massive teeth, continuously growing throughout their lives, were perfectly adapted for processing the tough, fibrous vegetation that characterized Caribbean forests before human colonization. Unlike true beavers, they were terrestrial animals that lived in burrows and rocky crevices, emerging at dawn and dusk to feed on the abundant plant life that flourished in their tropical paradise. The social structure of these gentle giants was probably similar to that of modern capybaras, with family groups sharing territories around the best feeding areas and water sources. Their slow metabolism and efficient digestion allowed them to thrive on vegetation that would be inadequate for most mammals of their size, while their thick skin and powerful claws provided protection against the few predators that shared their island habitats. The extinction of Cuban giant beavers coincides precisely with the arrival of human settlers in the Caribbean, suggesting that hunting pressure was the primary cause of their disappearance. These massive rodents, having evolved in the absence of large predators, possessed no behavioral adaptations for avoiding human hunters. Their slow movements and predictable feeding patterns made them easy targets for people seeking protein sources on islands where large game was otherwise scarce. The loss of these remarkable creatures represents more than just another species extinction. It marks the elimination of an entire ecological role that had persisted for millions of years. Cuban giant beavers were ecosystem engineers whose feeding and burrowing activities shaped the structure of Caribbean forests in ways we can only imagine. Their disappearance left vacant niches that have never been filled, contributing to the simplified ecosystems that characterize many Caribbean islands today. In the crystalline waters surrounding these tropical islands, another giant was completing one of evolution's most remarkable transformations. The Caribbean monk seal, which survived until the middle of the 20th century, represented the tropical branch of a family of marine mammals that had adapted to every major ocean system on Earth. These sleek pinnipeds had evolved in the warm, clear waters of the Caribbean Sea, developing adaptations that made them perfectly suited to life in tropical marine environments. Unlike their Arctic and Antarctic relatives, Caribbean monk seals lacked the thick blubber layer that characterizes most pinnipeds. Instead, they relied on behavioral adaptations to regulate their body temperature, seeking shade during the heat of the day and entering the water to cool down when necessary. Their streamlined bodies and powerful flippers made them graceful swimmers capable of diving to considerable depths in pursuit of the fish, crustaceans, and mollusks that formed their diet. The breeding behavior of Caribbean monk seals was tied closely to the seasonal patterns of tropical weather, with females giving birth to single pups on secluded beaches during the calmest months of the year. The bond between mother and offspring was remarkably strong, with nursing continuing for several months, while the young seal learned the complex skills needed for independent survival in marine environments that could be both bountiful and treacherous. What made Caribbean monk seals particularly vulnerable to human activities was their dependence on undisturbed beaches for breeding and their naturally curious behavior around boats and swimmers. Early accounts described these seals as remarkably tame, often approaching human settlements and even hauling out on docks and piers. This fearless behavior, which may have served them well in their predator-free island environment, made them easy targets for hunters seeking oil and meat. The last confirmed sighting of a Caribbean monk seal occurred in 1952, marking the end of a lineage that had survived the dramatic climate changes of the ice ages, only to succumb to a few centuries of human activity. Their extinction represents one of the most recently documented losses of a large marine mammal, a sobering reminder of how quickly human activities can drive even well-adapted species to oblivion. The story of Caribbean monk seals serves as a bridge between the ancient extinctions we've explored and the ongoing biodiversity crisis that characterizes our modern world. Unlike the mysterious disappearances that claimed Ice Age giants, the loss of these marine mammals was thoroughly documented, providing scientists with detailed insights into how human activities can disrupt marine ecosystems that had remained stable for millions of years. As we drift through these tales of recent losses, the boundary between historical fact and living memory becomes beautifully permeable. Some of the creatures we've encountered tonight vanished so recently that their absence is still felt in ecosystems struggling to adapt to their disappearance. The silent beaches where great auks once gathered in thunderous multitudes, the empty forest clearings where Cuban giant beavers once foraged, the crystalline waters where Caribbean monk seals once played in the tropical sunshine. These losses remind us that extinction is not merely a phenomenon of the distant past, but an ongoing process that continues to reshape our world in real time. Every ecosystem on Earth bears the invisible scars of species that have vanished within human memory, their absence creating gaps in the web of life that may never be filled by other organisms. Yet, even as we acknowledge these losses, we can find hope in the remarkable resilience that life has demonstrated throughout Earth's long history. The same evolutionary processes that created the vanished giants of the Ice Age continue to operate today, constantly generating new adaptations and possibilities. In laboratories around the world, scientists are working to understand and preserve the genetic heritage of endangered species, while conservation efforts are helping threatened animals find refuge in an increasingly human-dominated world. The stories we've shared tonight represent just a tiny fraction of the incredible diversity that has characterized life on our planet throughout its long and remarkable history. For every creature we've encountered, there are hundreds more whose stories remain locked in stone, waiting for paleontologists to uncover their secrets and share their tales with future generations. In the gentle rhythm of your breathing, in the steady beating of your heart, the legacy of all these vanished worlds continues. The same basic biological processes that powered the metabolism of woolly mammoths and giant ground sloths flow through your sleeping form, connecting you across vast expanses of time to every creature that has ever drawn breath on our shared planet. The molecules that compose your body have been recycled countless times through the bodies of extinct animals, carrying within them the atomic memory of creatures that gazed upon landscapes no human eye has ever seen. The carbon in your cells may once have been part of a sauropod's massive skeleton, while the calcium in your bones might have formed the shells of ammonites that spiraled through Mesozoic seas. These connections remind us that death and extinction are not endings, but transformations, with the substance of vanished life becoming the foundation for new forms and possibilities. Every atom in your body is billions of years old, a wanderer that has participated in countless experiments in the art of living, from the simplest bacteria to the most complex mammals. As consciousness fades into the peaceful embrace of sleep, let these thoughts of continuity and connection carry you gently into dreams where time itself becomes fluid and permeable. Tonight, in the theater of your unconscious mind, you might find yourself walking alongside the last great auks as they make their final journey to breeding grounds that will soon know them no more. You might swim with Caribbean monk seals through waters so clear that sunlight creates cathedral beams reaching down to coral gardens that knew no pollution or disturbance. You might share a quiet moment with a Cuban giant beaver as it emerges from its burrow to greet a Caribbean dawn that has been breaking over the same islands for millions of years. These dreams connect us to the deepest truths about our place in the natural world, reminding us that we are not separate from the great web of life, but integral parts of an ongoing story that began billions of years ago and continues to unfold around us every moment. The responsibility we bear as conscious witnesses to this magnificent history is both humbling and inspiring, calling us to become better stewards of the remarkable planet we've inherited. In the gentle darkness that embraces you now, surrounded by the quiet presence of sleeping life, you can almost hear the whispered voices of vanished worlds calling across the vast expanses of time. They speak of wonder and loss, of adaptation and extinction, of the eternal dance between stability and change that has characterized life on Earth since its very beginnings. These voices remind us that we are temporary custodians of a legacy that stretches back hundreds of millions of years, carriers of genetic memories that connect us to every creature that has ever lived. Our own species, young as we are in geological terms, has already witnessed the disappearance of remarkable animals and will undoubtedly see many more transformations before our own chapter in Earth's story reaches its conclusion. Yet, in this awareness lies both sobering responsibility and profound hope. We are the first species in Earth's history to develop the capacity for conscious choice about the direction of evolution itself. Through conservation efforts, genetic preservation, and careful stewardship of remaining wild spaces, we can help ensure that future generations will inherit a world still graced by the beauty and diversity that has made our planet unique in the known universe. The stories of extinct animals that have accompanied you through this long night serve as both lament for what has been lost and celebration of the incredible creativity that life has demonstrated throughout its long history on Earth. They remind us that every species that has ever existed, no matter how briefly, has contributed something unique and irreplaceable to the great experiment of consciousness and complexity that we call life. Sleep now, cradled by the knowledge that you are part of this continuing story, your own existence, a temporary but meaningful chapter in the vast book of life that is being written anew each day. Tomorrow will bring fresh opportunities to marvel at the living world around us, to protect what remains of our planet's biological heritage, and to add our own voices to the ancient chorus of creatures celebrating the miracle of existence. In your dreams tonight, may you find yourself surrounded by all the remarkable animals we've encountered on this journey through deep time. Their presence a reminder that nothing truly wonderful is ever completely lost as long as someone remembers their stories and carries their memory forward into an uncertain but eternally hopeful future. The dawn that will eventually break outside your window will illuminate a world still shaped by the long residence of vanished giants, their influence woven into the fabric of every ecosystem that surrounds us. In that morning light, you'll find yourself part of an unbroken chain of life that stretches back to the very origins of consciousness itself, a living link between the ancient past and the infinite possibilities that await discovery in the years to come. Rest peacefully now, knowing that the story continues, and that your own brief but precious participation in the grand narrative of life on Earth adds meaning and purpose to every breath you take and every beat of your heart as you sleep, surrounded by the invisible presence of all who have come before and the promise of all who are yet to be. The gentle currents of time carry us now to our final destination, where the echoes of vanished worlds merge with the quiet promise of dawn approaching beyond your window. As the last threads of consciousness weave themselves into the tapestry of sleep, we pause to consider the profound legacy these remarkable creatures have left embedded in the very atoms of our living planet. In the laboratories and museums scattered across our modern world, scientists continue to unlock the secrets held within ancient bones and fossilized remains. Each new discovery adds another piece to the vast puzzle of life's history, revealing connections and relationships that span millions of years. The DNA extracted from mammoth tusks, frozen in Siberian permafrost, carries within its molecular structure the story of how these giants adapted to one of Earth's most challenging environments, while the delicate bones of early whales preserved the remarkable tale of how land mammals learned to master the ocean depths. These scientific endeavors represent more than mere academic curiosity. They offer us glimpses into the fundamental processes that continue to shape life around us today. The same evolutionary pressures that drove the development of a mammoth's insulating coat or a saber-toothed cat's specialized hunting technique are still operating in ecosystems across our planet, constantly refining and improving the adaptations that allow species to thrive in their particular environments. The genetic innovations preserved in extinct lineages continue to inform our understanding of how life responds to environmental challenges. The hollow bones that made pterosaur flight possible provided the evolutionary template for the pneumatic skeletons that allow modern birds to achieve powered flight with remarkable efficiency. The complex social behaviors documented in fossilized trackways of dinosaur herds laid the groundwork for the sophisticated group dynamics we observe in contemporary elephants and other large mammals. Perhaps most remarkably, some of the adaptations we've encountered tonight are being rediscovered and re-implemented by modern species facing similar environmental pressures. The thick insulating coats that protected Ice Age mammals from brutal cold are being developed anew by Arctic animals adapting to changing climate conditions. The efficient metabolism that allowed giant ground sloths to survive on minimal food resources is being refined by desert animals, learning to cope with increasingly arid environments. This ongoing process of evolutionary innovation ensures that while individual species may vanish, their genetic contributions live on in the descendants that carry forward their molecular legacy. The extinction of specific lineages is balanced by the emergence of new forms, each building upon the accumulated wisdom of countless previous generations to explore fresh possibilities for life on our ever-changing planet. The fossil record beneath our feet serves as both library and laboratory, preserving the experimental results of millions of years of natural selection while providing the raw materials for understanding how life might continue to evolve in response to future challenges. Every sedimentary layer holds within it the compressed stories of entire ecosystems, their rise and fall documented with a precision that no human historian could match. Yet, even as we celebrate these connections between past and present, we must acknowledge our unique position as the first species capable of conscious stewardship over the evolutionary process itself. The choices we make today about habitat preservation, climate action, and species protection will determine which of our contemporary creatures will join the ranks of the extinct and which will continue their evolutionary journeys into an uncertain future. The responsibility this awareness brings is matched only by the incredible privilege of living at a time when we can appreciate the full scope of life's magnificent history on our planet. Never before has any species possessed the tools to peer so deeply into the past or to understand so clearly the connections that link all living things across vast expanses of time and space. As you rest now in the embrace of sleep, surrounded by the quiet presence of a world still breathing with the legacy of vanished giants, know that you are both witness to and participant in the greatest story ever told. The same cosmic forces that shaped the first primitive cells billions of years ago continue to operate through your sleeping form, connecting you to every creature that has ever lived through bonds deeper than consciousness itself. In the morning light that will soon illuminate your awakening world, you'll find yourself part of an ongoing narrative that stretches from the deepest oceans of the Precambrian era to the infinite possibilities that await discovery in the years ahead. The extinct animals whose stories have accompanied you through this long night live on not just in fossils and scientific reconstructions, but in the continuing adventure of life itself, as it explores new forms and possibilities on our shared planet. The tale of life on Earth continues to unfold around us every moment, written in languages we are only beginning to learn how to read, promising discoveries and revelations that will reshape our understanding of what it means to be alive in this magnificent universe. Sleep peacefully now, knowing that you are forever connected to this grand adventure, your own existence a precious and irreplaceable chapter in the eternal story of life's journey through time and space.